Good morning from my side. My name is Juergen Hoeller. I'm here to talk about the quite long and involved history of the Spring framework, which I've had the privilege to guide through its entire history, essentially from the very early beginnings in 2003 up until the very present. So the 15 years is actually a bit creative in how we count, right? It's from 2003 to 2018. It's a 16-year lifespan. The Spring Framework 1.0 GA release was actually in March 2004. So, well, that's 15 years almost to March 2019. So take the 15 years as an indicator, but the history is actually 16 years and counting in the meantime, which is a long, long time for a software product in an industry like this and in times like these. So I'll talk a little bit about the history in the sense of the challenges that we had and the major milestones that we went through. The subtitle, Evolving a Java Application Framework, is the key part here. We'll constantly be referring to the challenges of evolving an existing arrangement with code written against it, with backwards compatibility requirements throughout the times. And you may imagine there have been quite a few of those challenges in that time frame. So personally, I've started with this book, and back in the times, that's when people actually read software development books, still like hard copy, right? In December 2002, I got myself a copy of this book and read it over Christmas break. It's almost like 600 something pages, so it was quite a read. And I really liked what I read in there. There were a lot of original design ideas, just a lot of pragmatism in there. Back in 2002, Java was still in its rather early stages, in particular enterprise Java. Enterprise software development with Java was in early stages. So there was there was a lot of writing about it, and there was, of course, the early versions of J2EE and EJB being a topic. There was a lot of noise around enterprise Java, but nobody really focused on getting the job done. And I really loved the approach in here, in the book that Rod Johnson laid out. And it was not only a set of design ideas and a design philosophy, it was a lot of code. Basically an early version, an early prototype of an application framework that came as a download with the book. So I spent quite a bit of time looking at that code that came basically just as a download from the book's website. And I contacted Rod through the author forum, of course, 2002, no social media, right? So the publisher of that book, there was a feedback forum, and I contacted him on that forum and just suggested, what about taking the ideas, and in particular the code that came with that book, and turning it into a properly maintained open source project. And this is essentially the inception of the Spring Framework open source project on SourceForge. We uploaded the first version, I think it was early February 2003. We had to pick a name, because on SourceForge you can't really, SourceForge was the GitHub of the times, right? You can't really change the name afterwards, so we had to go through a phase of selecting a name early on when we created the repository. There was a bit of a couple of ideas, and there was a really fine suggestion by one of the people that got involved very early. He suggested the name Spring, and we picked Spring-Framework to make it unique as a name that is searchable and like a properly identified repository name. And it stuck from there, right? It's still called Spring Framework. The first version was 0.9 in June 2003, but just this half year, right, between the between the publication of the book and the 0.9 release was an absolutely intense phase. What we released as Spring Framework 0.9 was way more complete and just way more baked than anything that was written down in the book or that came with the book. Personally, I was, well, the trigger initially, I guess, for creating the open source project. So back to that storyline, I got in touch with Rod, and Rod was very willing to take it towards an open source project, but he did ask for in kind of sharing the load, sharing the workload. He was a consultant at the time, spent a lot of time writing that book, and he wanted to get back into consulting and to back into earning some money, right? Writing a book is mostly a hobby in this industry. So I stepped up, cut down on my regular job, and got fully involved from February 2003 onwards, and was already the release manager behind Spring Framework 0.9. So I personally took the responsibility for managing the Spring Framework core project as the project lead, as the kind of open source project lead, and as the release manager from June 2003 onwards already. And this is still the case to today. I've signed off every single Spring Framework release in these past almost 16 years now, every single maintenance release even. I'm a bit of a control freak, I guess, in that respect. So that was the 0.9 release. It turned into a 1.0 GA in not even a year's time. You may imagine that was an equally intense phase. We already chose the package name, org.spring framework at the time. We tried to create a first complete iteration, a first complete feature set to ship. At the time, the primary configuration model was XML. So web XML, the XML files that you use to configure Hibernate or any other tool. XML was actually already a step forward. Just a year or two before, it was properties files everywhere. So XML was at least structured and nested. So that's what we went with. We aligned with the conventions of the time. This is a very essential piece of the Spring storyline, that Spring co-evolves with the ecosystem, with the platform underneath, with the Java platform itself, but also with other open source projects. And we're trying to align with the conventions and the configuration models that other projects are using, so that the overall experience when developing with this kind of stack is smooth enough and consistent enough. In the Spring Framework 1 line, actually pretty early on in sometime 2005, we already started introducing some annotation support. So the @transactional annotation, which is a very essential part of the programming model in recent years, this kind of style. The @transactional annotation came already in Spring Framework 1.2, but it was a bit hard to configure. You couldn't easily switch it on. It was a bit of, you had to understand how the co-container actually processed it. It wasn't very convenient, but it was there as a programming model element. And it was only usable on JDK 5 anyway. And JDK 5 only got introduced in this phase in late 2004. So Spring Framework itself, as an open source project, as a core container, as a configuration arrangement, predates JDK 5. So everything that it did had to work on JDK 1.3 even and 1.4 at the time, where there were no annotations. So XML turned into the primary configuration model. And then there was this forward-looking support for annotations for people who could use JDK 5 and higher. Mentioning other open source projects that we typically integrated with, there were already a couple of well-known names. Apache Tomcat existed, at least in an early version already from like 2000 onwards, but really became a mainstream choice in that 2004 timeframe, 2004-2005 timeframe. Its alternative, the Jetty servlet container, was already very much a pretty well-baked arrangement at the time, and is still a primary choice for a web server for Java web applications. The Hibernate project, of course, delivered already a couple of iterations on its object relational mapping. So Hibernate as a brand name, Hibernate as a team, Hibernate as a project arrangement was already an important part of the ecosystem. There was of course also Apache Struts mentioned in the Struts era in the title. Apache Struts was a huge topic in the application framework, web application framework space at the time, and there was this typical combination of Struts for the web layer, Spring for the service layer, Hibernate for the persistence layer, even had a name like the Struts Spring Hibernate stack. But Struts came and went away again. It had a few years where it was the mainstream choice for a web application framework. It never made the switch to the Java 5 generation. It was a JDK 1.3, 1.4 based web framework that never really evolved beyond that era. And now it had a successor in the form of Struts 2, but that is a total re-implementation, has nothing to do with the original Struts, and never really established itself in the mainstream much at all. So this era is enormously important for the Java open source ecosystem. Many projects, not Struts, but the ones mentioned here, Eclipse, the IDE project was set up at the time. These names and these projects are very much still with us today. And we integrated heavily with them in every imaginable form. We kept writing a few books. There was one in between, the J2E development without EGP, that I was a co-author of, and then there was this third book, the first Spring Framework-centric book in 2005, written by us 5 gentlemen in this photo montage there. This book was actually already a sign of exhaustion on our end. We were implementing an open source project at the same time, setting up a company called Interface 21 at the time, trying to make a living through consulting and through trainings in particular, and writing a book about all of this. None of us 5 enjoyed writing this third book anymore. We were glad when it was done and changed course afterwards. We worked with book authors, we supported book authors in writing Spring books. We didn't actually write Spring books ourselves anymore. None of us 5 was ever involved in a book project anymore, as far as I know. But that connects back to the ecosystem story. We started heavily to work with the community. People around us, we supported local consultancies, local service companies providing some form of Spring support, some Spring trainings. We supported book authors, as mentioned. We supported third-party open source projects in integrating with the core Spring framework. So we spent a lot of time on community support. And turned into the next major release. Spring Framework 2.0 was already a pretty well orchestrated affair. Not as ad hoc as previous releases. There was even a release countdown on the website. It was quite professionally marketed already. We had an established company, Interface 21 at the time, that soon turned into Spring Source, a product company with support offerings, training offerings, and consultancy offerings around Spring. So we had we had variations of a business model around it. But from the framework itself, it was largely still focused on XML configuration, but in a more modern way, aligning with some other common products of the time, with namespace support, so XML schema namespaces, which we used for configuration namespaces, for convenient configuration, like a TX annotation-driven element, implicitly turning everything into proper shape for at transactional support, so like a single switch basically that turns on a container feature. This was introduced in that generation. And more annotation support for the ones who could use it. Spring Framework 2.0 was still very enterprise-oriented, and most of enterprise software development, even in 2006 and 2007, was in JDK 1.4 and not JDK 5. So no annotations for a lot of people. We had parallel support for the XML configuration model and the annotation model at the time, strongly focused on the annotation-based model, but we were pragmatic enough to have equal priority or appropriate priority for the XML configuration story at the same time. We still very much have several configuration models at the same time. There's no single model that rules them all, and the Spring Framework 2.5 generation is a perfect example, also from a technical perspective, how we try to balance these different requirements from more traditional enterprise development setups and more like forward-looking setups that really wanted to embrace annotations. The annotation-based MVC model got introduced in 2.5. We always had a web framework, kind of a Struts alternative initially, that turned into a major part of the framework itself. And what we know now as the annotation-based controller model in Spring MVC started emerging in 2.5. Another topic that that we keep coming back to, alternative JVM languages. Java is, of course, the primary programming language on the JVM, but then there's Groovy. Groovy was actually super popular in those times, 2006, 2007 onwards. Grails was a dedicated web framework built on Groovy and Spring, so it was kind of a combination of idiomatic Groovy language usage and the Spring framework infrastructure underneath. Of course, these languages, there were several JVM languages in existence. Many of them don't really reach any form of mainstream potential, but Groovy definitely reached the mainstream, not only through Grails, but later on also as the declaration language in the Gradle build system, for example, and for many purposes, for dynamic configuration snippets, for dynamic strategies in a Java-based setup, for writing tests with the Spock framework. So Groovy found a large audience and a lot of use in and around Java-based products, everything running on the JVM, of course. And from a Spring perspective, we strongly focused on integrating with Groovy, having a fine Groovy development experience. If you choose to use Groovy and Spring, on Spring, in combination, then it should feel smooth and idiomatic to you. That was an explicit decision we made at the time. But of course, our corporate story also evolved. Spring Source was relaunched as a US-based setup. Initially, Interface 21 was based in London, in the UK. This turned into Spring Source with a primary US company and some regional companies in like the US, in the UK, in Germany, in France. And of course, being a US-based company now, we had a US-based marketing department. And US-based marketing people have great ideas of how to visually represent stories. So this was one of the first major campaigns that came out of our new US marketing department. Weapons for the War on Java Complexity. I think it dates back to roughly 2007. If you look at the imagery here, right, like Spring battleships, TC server tanks, and DM server fighter planes. Spring, of course, is the framework we're talking about here. TC server was our Tomcat distribution, and DM server was an OSGI-based web application server distribution that Spring Source developed as a product at the time. But tanks and battleships and fighter planes, and yeah. I have memories of this period. This is a good indication of the problems of the time. There's nothing wrong with like Java complexity being a topic, but this was the last time we ever used this kind of imagery for marketing, and it never really escaped the US. But yeah, there's always a few kind of mistakes and sidesteps in every story. I guess this is one of ours. On a more open source oriented note, Spring turned into an ecosystem, a project arrangement. It wasn't just a single project anymore for quite a while already, but now it really was a wide range of like 15 plus projects. There was the Spring Framework Core project, which includes the core web support and web MVC. So it's pretty complete in its own right, but it had a couple of projects, quite a few around it, for more specifically purposed architectures, like Spring Webflow, Spring Web Services, SOAP-based web service interaction at the time, the still very popular Spring Security and very essential Spring Security project. On the bottom left, there's Virgo, which is our basically the OSGI-based DM server donated to Eclipse. There was TC Server, the Tomcat distribution. There was the aforementioned Grails, the Groovy-based web framework sitting on top of all of this. And a couple of interesting initiatives, more enterprise-oriented ones like Spring Batch and Spring Integration, and new and more short-lived ones like Spring Social and Spring Mobile, trying to provide programmatic login facilities for Facebook and Co, that sort of stuff. Very important, actually, initially just a little side project, but turning into a key role, a very important role in the portfolio now is Spring Data, an interface-based repository model with not only JPA support and JDBC support, but also support for NoSQL databases. So we had quite a few projects around the core framework, building a form of portfolio. There was no Spring Boot at the time. There was no real project bringing all of this together. It was basically a hand-picked selection. You made your choice, you used whatever you needed, and you built your own stack from it. That was the thing to do in 2009. So in the meantime, we were working on and towards Spring Framework 3.0 for quite a while already. It was almost 2 years in the working. The first time we had a JDK 5 as a minimum requirement and had a really complete and consistent annotation-based programming model. It was the first productized version of Spring that shipped add configuration classes, so like a Java-centric annotation declared configuration arrangement, basically allowing to express a full Spring-based application setup without any use of XML or properties, with no external configuration format, entirely in the Java language, using Java language facilities, annotations in particular. And it was also the first major revision of Spring MVC, introducing REST support. Basically, Spring MVC as we know it now is largely this 2009 generation taken forward. In terms of the corporate history, this was very much developed at SpringSource, but SpringSource got acquired by VMware towards late 2009. So I guess technically Spring Framework 3.0 is also the first release post-acquisition, but it was very much in the works before. And it turned into a generation. Spring Framework 3.1, Spring Framework 3.2, over the next 3 years, completed that picture. And to give you some indications of what that programming model looked like at the time, this is essentially 2009 state of affairs. If it looks like 2019, if it looks like a very current, very present arrangement, that's indeed the case, because the model didn't really change in the past 10 years. It only got refined. So the annotation-based Spring programming model as we know it now in the present actually dates back to roughly 2009 in this shape. Parts of it are even older. So I suppose some of you are familiar with the visual impression of this. This is a very Java-centric model. You implement Java classes, you put stereotype annotations on top, you demarcate certain qualities of service or certain service arrangements with annotations. Add transactional, which is the oldest of those annotations, is still in use to demarcate a transaction boundary on a method, automatically starting a transaction, calling the method, and when the call returns, we decide on a commit versus rollback. All happens implicitly. The annotation basically demarcates the scope, the role of that method. It marks the method as transactional. So there's also quite a bit of a readability story in here. So my book admin service here is a lazy service class, has an auto-wired constructor, and a transactional update book method, a transactional service method. So the names of those annotations were really meant to lead to nice enough readability at the source code level. We had a strong focus on making source code as readable and as self-expressive as possible, and to use annotations idiomatically. This took a while. It was in the works for quite a while, and it deviates from some other Java-based application frameworks that really went a bit of a different path in terms of what they used annotations for. So this is basically 2009 state of affairs, got refined over the next 3 years in 3.1, 3.2, and is very, very much still with us today. I've already mentioned configuration classes in all brevity. This also dates back, well, this actually dates back to Spring 3.1, so this is kind of 2011, I guess, but it's still very much the same today. Configuration classes with add-bean methods where you programmatically build the instances of the beans. There's no configuration format involved, just a dispatch to a factory method that in Java code builds the instance, can refer to other factory methods, can inject other beans and then return them when it's done. As a kind of alternative to a constructor, the core container infers bean definitions from add-bean declarations on such factory methods. So it basically looks through all your configuration classes and finds other beans through these add-bean methods. This little annotation up here at enable transaction management is the modern day way of opting into container features. So a few years back there was TX annotation driven in XML. This is the annotation based variant of it. Not a direct one-to-one translation. We tried to support the same kind of philosophy, this simple opting into certain container features, with an idiomatic annotation arrangement at enable annotations that are semantically and structurally different from the XML namespaces, but ultimately serve the same purpose. So we didn't just try to kind of port the XML model to annotations. There were other attempts that went into that direction. That's not what we wanted. We wanted to reinvent the Spring configuration philosophy with the use of annotations and the same degree of convenience, but with idiomatic naming of annotations and idiomatic use of annotations. And this is very much the mainstream programming model to this day. So even like 8 years later, hardly anything is different here. In parallel, we were prepared towards a spin-off from VMware. The entire group that we were in, basically the Java engineering group, Java open source engineering group at VMware, mostly Spring focused, but also a couple of Apache Tomcat committers and other projects around us, but all Java open source centric. Got spun off into a new company called Pivotal, a basically spin-off from VMware and EMC at the time. And Pivotal was set up with a project arrangement that came out of VMware called Cloud Foundry. And this is kind of the bigger picture that our efforts were meant to be a part of. So Spring, of course, as a Java-centric application framework, is usable for many arrangements, many kinds of stacks, many kinds of architectures, and was in widespread use already across the globe. But from the specific business model behind it that VMware then Pivotal used at the time, cloud-based deployment was already a strong topic. And this is an original image. So this presentation uses original images from the times. So this is also the original Cloud Foundry launch image there for Pivotal. And you can see that there's Java and Spring over here on the kind of framework side of the story. But of course, with Cloud Foundry and cloud infrastructure in general, there's much more to it. There's all the data stores, there's the different kind of deployment models, in-house clouds within the corporation, public cloud arrangements, different kinds of languages, so the ability to build a larger arrangement of microservices in particular, where you mix and match different languages and different kind of runtime architectures. So it was a much bigger picture that we were a part of now. Whereas previously at Spring Source, it was Java-centric enterprise development. We had a .NET story for a while, but it didn't really go much larger than this. Here we had a much larger and very different picture. And in modern day deployment, so fast forwarding to the present, of course, cloud deployment is still a key topic in this space. And Kubernetes and co, they radically changed the picture again from there. So it's not quite the same cloud as in 2013, but it's still very much the same kind of deployment model, the same kind of architecture that you work towards. So back to the framework itself. The next major generation, and a really major generation, was Spring Framework 4 in December 2013, already rolling this kind of bigger picture with cloud deployments and everything, the microservice focus in the back of our minds when we designed this. Spring Framework 4.0 was also paired by Spring Boot. The core framework is the foundation for what turned into Spring Boot 1.0. Spring Framework 4.0 evolved, of course, quite a few feature iterations up to 4.3. It is still probably the most popular Spring Framework version out there in production environments right now, just running and doing its job based on Spring Boot 1.5, which is internally based on Spring Framework 4.3. The focus is on annotation-based programming, on the annotation-based programming model, but we literally went through the entire code base, updated it for a JDK6 baseline, integrated with everything that was current at the time around us, still very much Java EE oriented in the sense of integrating with servlet containers, the newest crop of JPA persistence providers, and everything around us. So this is a very essential and very, very popular, even to the day, generation of the framework. There were a few subtleties that we introduced. So we focused on building custom annotations, like an annotation that you declare yourself and you compose it from annotations that the framework provides out of the box. So you can build a custom sort of shortcut, a custom stereotype that combines certain characteristics through meta-annotating your own annotation. And then wherever you need this combination of characteristics, you just use your own annotation, not repeating yourself, composing a number of characteristics into one annotation that you then keep using in your code base. So this is a new feature in the Spring Framework 4 line, for example. We use this approach in our own annotations as well to some degree. Modern day Spring MVC, REST controller, get mapping, post mapping are all built on this composable annotation model. But otherwise, it's very much still the same annotation-based programming philosophy that we rolled out in 2009 for the first time in that form, a refined version of it. However, we cannot stand still, even in the web architecture space. Servlet containers and the servlet programming model have been with us for a long, long time. Spring MVC is heavily servlet-based, very intentionally, so it integrates with so many servlet-based pieces of infrastructure out there. But now, a new topic entered our space, reactive architectures. And this is a key focus today. Lots of the things we do today in the Spring Framework 5 generation are kind of centered around the idea of reactive architectures. The key difference, as much as time allows here, right? The key difference is that in the servlet programming model, a web request, an HTTP request comes in, a thread gets taken out of a thread pool, assigned to you, you own that thread for building a response for that request, and the thread gets returned when you're done. When you're done parsing the request, when you're done writing the response. So for a potentially quite long time, you own a dedicated thread from a thread pool. This doesn't scale very well. JVMs are only really good at managing a certain number of threads in the low 3 digits maybe, like 150 threads, that sort of thing is still doable. But there's a lot of context switching and there's potential exhaustion if the thread pool is just, if 150 threads are built in parallel, all waiting on something, all building responses for something and used in parallel, then you may exhaust the thread pool. There are key problems in that kind of architecture that are unavoidable. And the Reactive manifesto, a reactive web architecture, tries to attack the problem space, right? To revisit that problem space from a very different perspective. with an event loop model, just as many threads as there are cores on the system, and a non-blocking callback-based architecture for expressing yourself. The outcome of our efforts here have been released in Spring Framework 5 a while ago already, like 1.5 years, almost 2 years ago already. We had the challenge of an existing Spring MVC web framework, servlet-based framework, that we of course wanted to keep up. It is still our mainstream web offering. It integrates with server containers so nicely, everybody uses it. So we decided to keep Spring MVC as it is and introduce a new web framework in parallel to it. We could have tried to kind of rebuild Spring MVC itself so that it can run on servlet containers and reactive pipelines at the same time, but it turned out that it wasn't as feasible as we thought it would be. So that is one part of the storyline, and we'll get back to that towards the end of the presentation with some very current efforts, but it is also about functional API design. Spring Framework 5 is very theme-driven. Java 8 baseline, the Java 8 baseline allows for a lot of things. Java 8 with lambda expressions and method references gives us language elements that we can work with. As framework authors, as framework providers, we closely integrate with the languages. And new language features allow us to design new framework features, new framework styles, new framework variants, embracing those language features. So functional API design is strongly about Java 8 lambda expressions and method references, and it is also about a new JVM language called Kotlin. Remember, we used to have Groovy as a mainstream language that we were embracing. Kotlin is very much the third one now. It's Java, Groovy, and Kotlin that we focus on. So to give you, again, a visual impression, functional bean registration is basically just code snippets like this. This is a Java 8 lambda expression used inline. This is a little bit similar to an add-bean method, right? Like a factory method, but it's not a factory method. It is a lambda-defined callback. We call it an instance supplier that you programmatically register. It is Java-based, Java-centric, but it is not using annotations and it is not using reflective dispatches. So it's different in style somewhat, but very similar in purpose to the configuration class @bean arrangement. So this is what we mean with programmatic bean registration in a functional style. We basically mean functional as in Java 8 functional as in Java 8 collection streams and the use of lambdas and method references. With Kotlin, we can use the same facilities. This is actually talking to the same underlying framework APIs with a few Kotlin extensions that are in there out of the box without you realizing it. And you can idiomatically use the Kotlin language to express the same kind of arrangement. This is a Kotlin function serving the same purpose as the Java 8 lambda expression, being an instance supplier for a bean that we register. And Kotlin as a language has a few really nice features like Kotlin functions, reflection around Kotlin functions that we're using here, or some of the structural variations that Kotlin provides, like the inlined method calls here. But let's get back to the reactive topic just for a moment. I already mentioned we introduced a new web architecture, a new web framework. And this is very much still the case today in Spring Framework 5, 5.1, 5.2. There's the servlet-based Spring MVC, shown on the left here, and there's the reactive streams-based WebFlux on the right. This is our solution to evolving the framework towards modern web architectures. It gets more diverse, it gets more sophisticated in allowing you to build very efficient web architectures. Spring MVC on the servlet API can get you a long way, and there are many applications built on it already that need to be evolved, but it can also get you a long way with new developments. But if you find yourself challenged by web architectures with a lot of concurrency, many potentially long-lived requests coming into the system, streaming, server-sent events, WebSockets, all of these topics, might suggest a reactive architecture, or these days maybe reactive messaging, like RSocket messaging, might suggest reactive architectures. We support both of them in parallel. We keep them aligned as far as possible, so they have similar configuration models, similar styles, but they provide distinct technical qualities. So it literally is a parallel implementation with a lot of alignment, allowing you to pick one over the other, but both of them within the familiar Spring programming model. So a reactive web controller looks just like a Spring MVC controller, but structurally, but in the annotation-based version here, it has a choice of returning reactive streams publishers. We can't really focus on how reactive programming works in this session here. Just a reactive architecture usually consists of methods and programming snippets that build pipelines, reactive processing pipelines, basically instructions for how to arrive at a result that are totally non-blocking, and there can be callbacks triggered. Whenever data comes in, we start processing them. Whenever the response is ready to be written, we start writing it out. This is what the runtime system does. The code itself just builds those pipelines or calls third-party libraries or repository arrangements that already build such pipelines, that are already based on reactive pipelines. And we just expose them to the web framework. The web framework knows what to do with them. This can lead to a totally non-blocking architecture within a still very familiar programming model. There's a functional registration version of all of this. This is the same kind of code, more programmatically centered, very similar to RX Java programming, if that rings a bell maybe. That is our way of combining functional and reactive. And in recent times, this is already Spring Framework 5.2 territory, so a little forward-looking. We're actually in 2019 now. We even have a reactive transaction arrangement now, which we have been shipping in the latest milestone, is about to be shipped in Spring Framework 5.2 GA in July this year. So that even the good old transactional annotation, 14 years old as an annotation, now gets reactive transaction support. If you annotate a method that returns a reactive streams publisher, like Mono and Flux are the reactor, the primary reactor API types for reactive streams publishers. If you put a transactional on it, there's now an SPI for it. We know what to do if you are trying to add an annotation, add a transaction boundary through an annotation to a reactive pipeline. So with certain limitations, we can decorate the underlying reactive pipeline and expose a transaction context to it. Our new R2DBC project, this is kind of a reactive equivalent of JDBC for reactive streams-based data access to relational databases, comes with an implementation of this transaction manager SPI, integrating with the good old Spring programming model in a reactive arrangement. And last but not least, also a very up-to-date topic that I'm leaving you with here is RSocket, reactive streams-based messaging, processing architectures for messaging where message payloads come in and message payloads go out, but using reactive streams for a non-blocking messaging callback. A new topic in Spring Framework 5.2 that covers new ground, covers new territory. So reactive programming is not just for WebFlux, for web architectures. You can now also build messaging architectures with a reactive streams foundation within the familiar Spring programming model. A very similar programming model to the use of the Stomp messaging protocol on Spring or the use of GMS with Spring. A similar programming model, but on a reactive streams-based messaging architecture. There are a couple of other challenges, just as a side note, that we deal with these days. There's a new JDK release cadence where every half year we get a new JDK release. So we also had to reinvent some internals within the framework and some ways of handling bytecode so that a Spring Framework release that you choose now can be used on JDK 8. That's the minimum. It can also be used on 9, on 10, on 11, on 12. And if JDK 13 goes out in September, Spring Framework 5.2 will be ready for it already. So there's always challenges, and we're out of time anyway, but I'm leaving just a name with you. GraalVM as an alternative VM implementation coming out of Oracle is also very much a topic with us today, where our goal for the next iteration in Spring Framework 5, Spring Framework 5.3, is to provide an out-of-the-box arrangement where you can even use the familiar Spring programming model to build a native image, to deploy a native image eventually, with standard Spring programming model elements and an out-of-the-box story for creating the reflection configuration for it, towards the very modern day and very forward-looking native image modeling GraalVM. So there's always challenges around us that we're working towards. And first things first, we're going to ship Spring Framework 5.2 in July, which is basically the culmination of the story as far as I've told it today. The only exception is the GraalVM native image topic and some forward-looking OpenJDK support for upcoming OpenJDK features. That is coming in Spring Framework 5.3 next year. Software is never done, frameworks are never done, we are never done, so we always have a plan for what's up next. And I hope I was able to share a bit of history, also a bit of the challenges and how we go about it, and even a couple of forward-looking notes with you today. So thanks for your attention. If there are any questions, I'm happy to have a conversation. Just catch me right after this session here, in the room or outside of the room. I'm around. I'm also around tomorrow, part of the open source panel in the afternoon, 2:30 p.m. All right, thanks.